Welcome to another episode of TechUnhinged, where tech gets human. I'm your host, Rabia Javid, and joining me today is Chris Colinsky, CTO and Principal AI Engineer, who's been building for the web since 2003. He's led engineering at companies like Goop and MeUndies, currently heads up the AI stack at Howl, and when he's not doing that, he's architecting open source frameworks for LLM-powered pipelines. Welcome to the show, Chris.
Hi, thanks. Appreciate you having me on.
Well, Chris, you've been building for web since 2003. For someone who hasn't been tracking this closely, what actually is an LLM and why is everyone suddenly trying to wire them into their systems?
Good question. LLM, large language model, it's just a new form of prediction, but at scale has an attention mechanism to better predict what it should say next or what the next token is. But it's large because it's billions of parameters, unlike models in the past where maybe thousands or millions. I think the other key thing is it's trained on the readable internet, so web scale data makes it a bit different. And at that scale, prediction looks like reasoning, instruction followed, and knowledge, and other things like that. So it's a bit of a illusion, if you will. It's not, in my opinion, at least, true knowledge or understanding. It's just very deep prediction.
All right. That's
Why
great.
now, I guess? Yeah, the tech's not new. The ideas aren't new. It's just a slightly different approach to it. It's just now it's accessible at scale, right? The cost versus the ROI you get from it is debatable sometimes. But yeah, in the past, 6 months for an ML project, you get some APIs. Today, you can parse, extract your data structure, translate, classify, summarize. It's all pretty easy. I think that's what makes it different. For a regular software engineer, it's just a new type of API. And I think that's how most people use it. And there's different layers of usage. There's those that use APIs. There's those that go a bit deeper and do what I'll call real AI engineering. And then there's the people who build the foundation models themselves.
Yes. And also, what's the simplest way to explain what these models can and cannot do, especially for people who've been burnt by the hype?
It's pattern matching at scale, not true understanding. So it's, I think the key thing to understand is it's probabilistic, not deterministic. You won't get the same answer twice. You get similar answers if you do it right, but not necessarily the exact same. I think the hardest part is that it's confident even when it's wrong. That can be the dangerous part of it, right? And it's hard to spot that. Evaluation is really important. At the end of the day, it's what makes it reliable and usable is really the engineering around it. The model is just one thing. And I think people overvalue the model and what it can do. And just, I see this on the business side all the time. Just LM can do this or, use the Gemini API. Well, it's not actually a Gemini API. There's, you can call the models and get the raw language model output and use it that way, but you can't use the agent Gemini as an API. And I think people have a lot of misconceptions about how things, work in that sense. Things that maybe it's not good at, or like deterministic correctness, math and counting, real-time facts, because the training has a cutoff. Like I was using Claude last night and it said, well, this thing happened, recently, and my training cutoff was January of this year. Sorry, I have to look that up. So they're becoming at least aware of their limits a bit, right? I think that the most dangerous part is that subtle wrongness can compound over time, and that's really challenging. And they're definitely not going to have, any kind of novel reasoning beyond their training distribution.
So 2 decades in, what genuinely feels different about building with AI versus everything you've built before? And what just looks new, but is actually the same problem engineers have dealt with previously too?
I don't know if this is necessarily new, but everyone's an expert at AI, right? And it's really easy to fake your expertise more than past. Like to master, machine learning was really hard. You had to know the math. You had to be, in the weeds, with a scikit-learn or Keras or something like that to, really do the work and speak, coherently about it, understand, things like cosine similarity and stuff like that, which is a cornerstone of old school, recommenders and stuff. But, that's not the case today. It's easy to be an expert. It's easy to fake that you're an expert. I mean, you got people who've never written code, writing code and winning competitions at OpenAI even, right? I mean, take me for an example. I participated in the OpenAI parameter golf contest, which was like a pretty extreme model training exercise that was all about efficiency, bytes per bit, and using Claude. I didn't get on the leaderboard because it was first to lowest score or SOTA, state of the art. But if you looked at it pure score wise, I would have got 7th out of 1,300. And I had never worked with model architecture prior to that. I'm technically minded and I wrote my little LinkedIn post about it was more about how my engineering manager skills is probably what worked most. I could guide it, make judgment calls when this was the dead end, what was working, what was not, that kind of thing. And I think that's kind of what happened there. But I'm not an expert in model architecture, but I did well in the competition. And I think that's definitely new. Like people weren't able to do that before. I would say old and new is security, totally different types of security problems that you never really thought about before. As I mentioned before, probabilistic outputs, which people are definitely not used to. They're used to like more like idempotency, getting the same thing every time, or it's an expected change. Like if I ask for the time, I'm expecting to get the time, even though the answer might be different, or the weather, but the shape of it and the way it's presented is the same. But I think the biggest difference, or what's new for me anyway, is that it's a natural language interface. You're not getting parameters, you're getting a sentence. And that's challenging for a lot of people, right? It's not necessarily new, it's just new to the masses and how we think about software engineering and the way we take input. Same problem, but rebadged. I would probably say just software engineering itself. I think everybody seems to forget that's really what this is. Vibe coding and, I can do it and this and that, but like doesn't mean you're going to make something that's going to go into production or be the one that wakes up at 3 a.m. when something doesn't go right. And I think that's the biggest challenge about, kind of going back to my other new, like people can fake it. If you don't really understand the domain that you're working on, like what it takes to really build a production app, you don't even really have to be like a software engineer and all these things. You could be a really technically minded product manager, as an example, which, I think is a category where people are doing really well with these tools because they understand tech, they understand deployments, they understand the step and the process, what characteristics make up a good application in production, like observability, security. They understand the checklist and they can make sure they happen, even if they don't necessarily understand exactly what they are, but they're still able to do software engineering in that sense. But a lot of people don't have that experience, and then I think team structure, also, people think, oh, it's radically changing, but no, it still need the same skills. It's just different tools.
A lot of companies are sitting on systems that are 10, 15, or 20 years old. When leadership says we need to modernize and bring in AI, what does that actually mean in practice?
It means they want to bring AI in and have no problem definition. It's a solution looking for a problem. Usually it falls apart because you have an existing bad process you're trying to automate, right? It's just going to amplify what you have, more or less. Like your skills, your process, your code base, it's going to amplify that, right? Unless you take the steps engineering minded to go fix that first, you're kind of just piling this new shiny thing on top of whatever you got. I think the other biggest problem, and I don't really understand this, is no good success criteria. I just want to use it. AI will make it better. Well, how and what? I think people have lost sight of what business objectives really are. Like your business didn't change because of AI. Maybe if you're adopting like more like an AI product or something, but for the most part, your goals, revenue, sales, whatever they are, those haven't changed, and AI will maybe help you get there differently or better, slightly faster, more optimized, whatever the case may be. Still has to work with an existing system, work with your business. Your business didn't change overnight because AI showed up, right? Other problems is your data's not ready, you don't have APIs that it can utilize, or more importantly, it doesn't have a true architectural home. You just kind of bolt it on the side or use some service off to the, out in left field and try to make it work with whatever you got going on, like in AWS or something like that. Right? There are a lot of areas where it can be really tough from the get-go.
There's a version of AI transformation, Chris, that's mostly cosmetic. A chatbot on top of a broken system, some dashboards with, AI powered in the label of it. What does real transformation look like versus the version that's mostly just for the press releases?
You got to modernize first, right? Like your whole stack has to come along with it on the ride, right? It's going to expose everything, every weakness you have in your foundation, and as you said, they might skip the foundation and build a demo on top of it. Probably will never even reach production anyway. It's a lot about data. It's not accessible. It's in silos. It's not queryable correctly, low latency. Those are all kind of problems you're going to have to deal with. For me, when I think about a project, it's like the first part is predominantly planning, then you have some execution, and then now I layer on AI at the end. It's like, it's the end. It's the last thing you think about usually. It's not my first thought, like, how do I solve this with AI? Like, I solve the problem. If AI happens to be the right tool at any point or component of the problem, then you can apply it, but it's not what you reach for first, right? If you're deploying it, it's, maybe you deploy it one piece at a time on top of the legacy system. Take maybe more like a strangler fig approach, like it's not a rip and replace, kind of pick away at your old systems one component at a time until you generally replace it over time, or pick a workflow workflow that AI might add value to, or prove a new concept and then expand on it, right? Start small and grow from there, right? These are ways you can be successful with it. And at least in practice, what I read, what I've experienced myself, or, how you approach it.
Absolutely. All right. So, Chris, Stack Overflow recently put out a piece arguing that most AI failures aren't really AI problems, they are data problems, bad metadata, missing context definitions that quietly shifted over the years. Does that match with what you've seen?
Yeah, for sure. That is definitely the key issue. And there's a couple of reasons. You could be missing data. Like, I want to build this thing and it requires, 3 types of data. You have 2. Maybe you can't get the other one. Maybe it's not licensable or accessible or just missing for some reason, right? I see that happen a lot. Although not necessarily unique to AI, it becomes more apparent because they're rushing into it. Like, I want this thing now. You don't have everything you need. Like, why not? There's pressure there. It's in the wrong format. It's not queryable. It's low quality. You don't know how to deal with those problems in the first place, right? Those are all issues. But, then you come into like governance and lineage, definitions, all the things nobody wants to think about, the inglorious stuff, right? Those are, really all pre-AI and the area that most people skip. And now with AI, it's just becoming more apparent, like, hey, you weren't even really doing engineering correctly before in the first place. And I'm going to amplify that, as I mentioned before, right? And then the other part, is that the model doesn't really have tribal knowledge of your business or whatever it is. The humans were always silently doing this in the background and dealing or working around the bad data themselves. Now the model just believes it, and you have to, it doesn't really work.
There's also another research that says that 62% of the companies experience pipeline failure every single month, averaging 3 hours of downtime each time. And AI-powered self-healing is being sold as the answer. Is that even a thing?
It sounds like a vendor selling a cure. But it's like observability first. You can't heal what you can't see, right? Into detection, so schema validation at the boundaries, health checks, anomaly detection, using metrics, idempotency, checkpointing, deterministic recovery playbooks. These are all core engineering things that you would do anyway, right? Like maybe AI can help you reason a little bit better, do some human in the loop components for you, in the middle of the night, help with triage, that kind of stuff. But I think that self-healing is something that most people are not doing, right? It's a lot harder to understand that. It's maybe not like writing its own code self-healing, but let's say it's like in the lens of quality assurance, right? You're testing something, it's a live dynamic environment, your test case isn't perfect. Can it adjust its test case to understand, is it really working or not? Is this a temporary blip? I think that kind of self-healing is where we're going to see things first. Writing its own code over time, I don't know, that's a larger problem. And most offerings don't even, think about or offer that kind of stuff. That's really custom work that only probably the biggest places are doing. I don't see it really coming up much. And if you're, most environments don't even need that in the first place. It just depends on what you're talking about, right? I work in like small to medium sized $100 million companies, not a concern, more or less, right? They're just trying to get cloud right in the first place, let alone layer on AI, And so, those are all like the things that really matter. And maybe what self-healing really looks like, it's just a little bit more sophisticated version of what you should have been doing already. This is part of the reason why I came about with Open Armature, is that it makes things like auto recovery possible. It's not self-healing, but it's part of that, process, recovery orchestration, checkpoint retries, observability. They're all first class primitives in the framework, right? It makes it easier to deal with because it's baked into it, and not something you have to custom write each time or whatever, right? Triage or remediation is just another node in the graph ultimately. And that's kind of how you have to think about it. As I think I mentioned before, it's more about the engineering around it than it is the model itself.
Chris, traditional systems are deterministic, same input, same output every time. LLMs aren't. The same question can get a different answer depending on the model version or how you word it. How do you build something reliable on top of something that's designed to be unpredictable?
Yeah, I have a strategy, catchphrase, I don't know what you're going to call it, but I talk about it as calculate first, reason second. Don't let it do the math. Don't let it make up facts. Like, do all that pre-work first, do it really well. I think about it as like ECR, extract, calculate, and reason. Retrieve, derive structured data, pre-calculate values, just like you might in like an analytical pipeline or a financial workflow, right? Don't let it figure that stuff out. Do that up front because it's totally possible. It's just the way you always did it, right? Compute your totals, taxes, dates, counts, reconciliations, right? Math should never be the model's job. And then lastly, you give it assembled facts. And it's not just I retrieve some documents for you. You've actually done some work over that information that you pulled from the database or your vector store or whatever the case may be. And then the LLM can interpret, summarize, decide, summarize, you know what I mean? But it's doing it over verified numbers and facts. It didn't compute or have to figure anything out on its own. You gave it very clear direction with all the information it needs to succeed.
Moving to the next question, RAG, retrieval augmented generation, where the AI pulls in relevant documents before it answers, became the default almost overnight. You actually built a graph-based version of this at Lunar Command. What wasn't working with the standard approach that pushed you in that direction?
It's a little bit different. I mean, I did it because I needed a deterministic world state. It's actually graph-based retrieval and action generation because it's for a game. It's a little bit different, but same core principles, right? You know, in this case, I use the LLM as a textual renderer, not the game master itself. The graph is the source of truth, right? What wasn't working, I guess, would be, you know, fuzzy semantics similarity wasn't really helping me. There was no structural guarantee of world consistency. Like in this case, like if a door was locked and now it's suddenly open, an NPC forgot that he just talked to you. You know, the physical laws of the world shift based on how it perceives it, right? Doesn't work. It makes for bad game experience. And these same principles apply to like customer service or anything else, you know? And so using a graph as a deterministic state engine and then layering on the LM as a generative narrative layer worked extremely well. As we mentioned, most AI failures are related to data. You know, having a graph really works. But in this case, it's not just, you know, a graph gives you more than just like document retrieval. It can structure relationships. But in my case, I use it, you know, not just for this thing's related to that thing, but it's like a spatial relationship. It's near you. It's in the room with you. You can actually touch it. Temporal changes, things happen over time. You can do that. You can facilitate movement. You can change edges, right? It's a distributed state model. Like for conversations, as an example, the NPC node will hold the conversation template and all the various pathways the conversation can go, but the history as it played out lives on the player over time. And then when they have a conversation, you interleave the history with the template, and now you have reconstructed the past and have the correct next step to, you know, you're still building a message list at the end of the day, but you're doing it correctly. And this, you know, ultimately helps long-term memory and keeps your contact window small. There's all kinds of things you can do in this situation that I found to be work a lot better than like traditional RAG. You know, you can have retrieval problems, stale data. You know, there's a lot of reasons why RAG system may produce wrong answers. And there are solutions for those. So I say do your own research. My situation was a little bit differently because I had to create a consistent experience, right? A bit more challenging, I think.
Teams are spending 15 to 25% of their AI budgets just on tooling to support the data layer underneath these pipelines. Is that the industry which is growing up, or proof that the underlying problem was never really solved?
I don't think it was ever really solved. So we sort of touched on this earlier, right? Data integration, quality, semantic drift, never solved it before. Never had to care about it, maybe, right? It's more important than it used to be. You know, things that you tucked away in your data lake and, you know, in Glacier, right? Like, oh, now I suddenly care about all this stuff. How do I get it back? What do I do with it? Nobody's touched this stuff in a long time, right? AI didn't really create this problem. It just removed your ability to ignore it, more or less, right? I think that's the big thing. And it's forcing teams to grow up. You know, you're finally treating data like the true foundation that it could as a first-class citizen. You know, you can't just pretend the model is the product, right? Your data, your information, your process, that's everybody has the model, right? I can access the latest and greatest foundation model, same as you and same as everybody else, right? It's what you do with it and what you feed it is what makes the difference.
You also hinted upon open Armature earlier, but we never really talked about it at length. So it's one of the frameworks that you've, you know, built on your own. What made you build it rather than, you know, buy? And what does it actually solve that the existing tools probably weren't?
I struggled with some of the, I won't name them, common tools you probably can guess. You know, they optimize for chat-shaped agents, right? Designed around conversation loops. You know, that's very difficult when you need a deterministic multi-stage pipeline. You know, LLMs could be worked in the mix. Like at one step, I might need it to reason or classify for me. It's not an agent per se, right? You know, these frameworks defaults will push you towards modeling everything as a message and LLM control flow, which is hard to, you know, shove a data pipeline into that. I need LLMs are a great tool for analytics and analysis. I use it for classification all the time. Or even to assess data quality or there's all kinds of really great things it's good at, but it's not necessarily an agent. Everybody says, oh, I need an agent, but you most likely don't. You need a workflow that has LLM capabilities or reasoning capabilities baked into it. I also currently work and have in the past in heavily event-driven environments. They lack first-class support for that. Things that you can't interrupt it. If you do, you have to do it while you're in the current session or it's still in memory and wherever it's running, right? You can't save state, kill the instance later on, even a month later, spin it back up and start off where you started, right? Like most of them can't handle that. They're mainly designed for human in the loop right now. But, you think about it like an agent handling like a call center, helping someone over time, dealing with that in any reasonable way or dealing with a failure and then recovering from that, not really happening there. A lack of first-class support for MCP in the real world. They assume you're only connecting to MCP servers that are always on and probably hosted by someone else, when in reality, when you're building your own MCP layer on top of your existing fast API REST services, you don't leave them on all the time. So a lot of ways, they suspend when they're not being used. You don't want to pay for these things to be on all the time. So, I had to write a custom wrapper around that fast MCP client to deal with wake ups and retries to get a machine out of a suspended state. I ended up just writing a lot of custom code on top of these things. And I was doing the same thing over and over and over again. And so I took about 10 projects, looked at all the things that I kept doing over and over again, and then designed my own approach to it. It's designed to not only overcome these shortcomings, it's designed for LLM-powered data pipelines and tool calling agents, right? And I think the key there for me is that pipelines and agents now share the same primitives. The engine is agnostic about if you're doing control flow that's deterministic or it's an LLM kind of component, right? You don't have to have separate frameworks. You don't have to have awkward glue, none of that stuff. Stateless workers can cross-process resume, as I was just talking about. Work state is durable. It facilitates state migrations, so things change over time. If you upgrade your agent in between sessions, you can, do a state migration and deal with that and recover, and you remain in control about how that happens, right? I think the other thing that I did that was a bit different is I started with a language agnostic specification with conformance fixtures, so that every language implementation would work exactly the same, but leave the implementation up to the language. Obviously, TypeScript and Python are going to be, written a little bit differently. They have different, inherent capabilities. You don't want to port a Python implementation to TypeScript. You want both to sort of come from the same origin story, if you will, right? So that's the approach I've taken. I have a very usable Python implementation today. I'm already using it in production. I'm working on getting support, getting others to get into it. I'm really hoping it gains traction. It's relatively new since sort of the first of the year. And once it gets a little bit further, then I'll release a TypeScript version as well. It's just that the ideas behind it are more enterprise grade, if you will, durable execution, event-driven capabilities, really meant to fit in with how I build applications already. But now I want to, I want to properly mix in an LLM component. I felt like I didn't want to reinvent that wheel every time.
Also, Chris, you've built across e-commerce, automotive, and creator platforms, all with different rules around customer data. When does the risk of sending sensitive data to a cloud API tip the balance toward running the model on your own infrastructure?
I would say in practice, I don't think we really felt we had to send sensitive data to the cloud, really, from a production perspective, right? In limited cases, when we did need to, we then use self-hosted. Big fan of Mistral Small 3. We use it a lot. But we also use Gemma and things of that nature. There's a lot of really great small models. I think the perception, just as a quick tangent, that everybody has to use the latest and greatest model, whatever. Not true. One of the things I think people also don't think about or run into problems is cost optimization. This could be a really great way to do that. As long as your production decisions are clean, and you control how it works, it's your product, right? You don't have to do these things. There are other ways to solve these problems. I think the bigger issue is on the business side. These users are pulling CSVs out of your BI layer, shoving them into whatever tool. And from an IT perspective, you lose control over that. Some AI platforms that you pay for, ChatGPT or Gemini, if you're more on an enterprise plan, are, probably not going to use your data, but you're still taking sensitive data out of your system. They're just saying, I won't train on it. but your users are now creating new behavioral patterns, or at least they're more obvious than they used to be, to like pull data out of things that they shouldn't and put it somewhere else that they shouldn't, whether it trains on your data or not. And I think those are the bigger issues I see from a business perspective. You can design the problem into a corner and deal with it properly if you think about it from a design flow perspective in your product, but it's the non-product stuff that you don't really have control over. And true human behavior of these tools, again, it's going to amplify that. A lot of users just want to pull it out and stick it in Google Sheets and send it around. Now they have more things than Google Sheets they can shove it into and get value out of it. Spinning up free accounts and stuff like that to bypass maybe, if you're not in like an enterprise structure, your IT is not going to lock down your laptop or what you have access to. There's a lot of holes there.
Also, Chris, as AI goes deeper into how these systems are built, does the team that built the old system have what it takes to run the new one? Or does something have to change there?
Yeah, I think it depends heavily on engineering leadership, probably more than anything else. How you approach it and how you lead through that. If you invest in your people and want to continue to get return on that, then you got to put time into training them, give them the tools, help them understand how to use it, bake it into your project plans, how you communicate, do your one-on-ones, your code reviews, when you team up and work on stuff together, right? And you pair up, baking that in as a leader or a mentor is really key. I think a lot of teams can and should be able to evolve. Are they given the chance, or are they set up for success or not? Right. Mindset and practices and org structures might need to change a little bit or rethink how you approach stuff. But, in reality, usually non-engineering leadership will want teams to evolve. They want to say their companies, using AI, but then they don't provide any support to do so. Money for training, time to learn, just figure it out as you go can be dangerous. And it all starts at the top on this one, I feel like.
A recent study found that roughly 1 in 5 companies in retail, finance, and healthcare are actually running AI in production. The other 4 are still watching. What are those 4 concretely falling behind on right now? Not in theory, but practically, if we look at the bright side of AI.
I think the reality is they're probably using more AI than they think or realize because it's through the lens of their vendors, right? Tools and platforms they already use and pay for are adopting quickly. If you use Figma, now you're using AI, right? Whether you realize it or not. And I think that's a great way to go, honestly. There's different, layers in which you can use AI, and it really depends on your engineering culture. Do you have engineers in-house? Do you outsource? Some companies, especially small e-com, have like no engineer or struggle to keep engineers on staff, or they rotate heavily because they're like on Shopify or whatever. No offense to Shopify. I think we're not running AI usually means we're consuming it, but didn't know it or realize it or thought about it at that level, right? I think there's always going to be a gap between those that build and those that use ultimately. And that's really what this 1 in 5 means to me.
So Chris, last question for a CTO or an IT director listening to our conversation today. What advice would you give them when it comes to, where should they start with AI perhaps?
You just got to start using it. Use it daily. Use AI search mode in Google. Gemini, it's baked into your workspace. Have it help you with your Google Sheets. Have it help you, one of my new favorite things is just the Ask Gemini thing where it slides out, and it can like help you write an email real quick. It can help you respond to something on LinkedIn maybe. You'd be surprised the context it has because it can kind of see what you're actively doing. Perplexity and others have that kind of functionality. And I think that's super helpful. It's more of like a casual, easy way to introduce yourself into what's possible, right? And those are really great use cases to start to wrap your mind around about what works and what doesn't, or dig into like a heavy chat interface. And it doesn't have to be work orientated. I built a mountain bike recently using an older frame because I wanted to go full suspension, and it had like all kinds of weird compatibility problems. Gemini worked me through parts compatibility, build a list of parts I needed. Every part I put on there worked, and I had deep conversations with it about like how I was going to assemble this thing, specifically for downhill mountain biking and picking the parts. And some I had to buy used, some I could buy new, how they can fit together, how I made parts from different eras work together, how I could bridge those gaps. I was kind of blown away at how it helped me in the real world doing something non-digital. And so looking for ways in which it can, help you out, like build something at home, do an electronics project with your kid. It doesn't have to be business, right? You can make it fun too. You're still learning how to use and work with AI. And then from there, you can get in, like try to prototype something. It depends on your role, I guess. If you're business focused, maybe help it with writing. You can have it help you at home. Conversational discovery is something that I've been deeply involved with at work. And a lot of the AI products are around providing data related to that. And so, using AI to help you shop and, getting my wife a Perplexity a subscription, it, like, was life changing for her. you know, and it's just these, you got to start small, but start meaningful, I guess. It's like, you want to learn, don't read the encyclopedia. That's tough, right?
Yeah.
Or you want to learn like a new technology or try a new framework. If you don't have something that's interesting you to build, a hello world or following some random tutorial is terrible. It's hard to engage, right? So
Yeah.
make it personal. Make it, something you care about, and it's an easy fit.
No, I think that's a great piece of advice, Chris. And thank you so much for this insightful and grounded conversation with us today.
No, I enjoyed it. It was really great. I appreciate you having me on.
Thanks a lot. And to everyone listening, thanks for joining us on Tech Unhinged. Until next time.